All right, welcome. This is Unit 5. This is page 10 of your note packet. We did some graphing with the logs and looking at the exponential first and then switch them to the log. So anytime we do this, as a reminder, I'm going to do the exponential first so I can just flip it for the inverse to get my log. So when you start looking at the top of page 10, it says graph the following, start with a parent graph of log base 2 points. So I'm not worrying about those to begin with. So if this is base 2, I'm thinking of the exponential to the x. I'm thinking of -1, 0, and 1. I do 1, 2, and 1/2. When I'm doing log base 2, I switch them so my x's and my y's are the reversed. So I have 1/2, 1, and 2, -1, 0, and 1. So I don't memorize what the log base 2 points are. I work with the exponential that I can get quickly and then just switch them for this. So when you're working with logs, as a reminder, if it's inside the parentheses, these are movements right or left. So if it's x minus 1, I go right 1. So my initial points for log base 2 of x is 1/2, -1, 1, 0, and 2, 1. So right now my asymptote went right along the y-axis. Alright, so right now it started off as x equals 0. Because I'm moving everything right 1, the asymptote line also moves with it. So it's important to remember that the asymptote is moving right along with the graph. So the asymptote line is there at x equals 1. And the graph just sweeps right by close to it and goes off to infinity here and down to -infinity on the left. So whatever your base is here, you're looking at that exponential. So in the second one, because I'm using base 4, I'm thinking of what 4 to the x is first. So -1, 0, 1, 1, 4, 1/4. So log 4, I just flip my numbers. Switch on 1/4, 1, 4, -1, 0, 1. Okay, the bases for the exponentials, these are inverses, they just flip from each other. So when I'm asked to graph this, I think about what this graph does first, and I get those points and then just flip them. So 1/4, -1, 1, 0, and 4, 1. So a lot, these will look like each other. So initially, the log base 2, it just was a more compact graph. This one goes up quicker, goes up a little bit slower as we're going to the right. Now this plus 2 is just shifting. Now this is going up 2. So each point, whoops, sorry, up 2. This one up 2. This one up 2. The asymptote line, sure, it went up 2, but really it just stays right along that 0, so everything shifts up 2, but that asymptote is just right there, staying right there along with it. So it's very close at x equals 0. Now you can start seeing some of the patterns, and that's fine. If you can see them and you're good with those, that's fine. Otherwise, the base is here at 3, so I'm doing 3 to the x. 1, 0, 1, 1/3, 1, 3. And so if I log base 3, 3, 1, 0, 1. So 1/3, -1, 1, 0, 3, 1. Okay, so your asymptote right initially is right here along the y-axis. For this one, I need to go left 2, which means the asymptote shifts left with us, and up 1. Okay, so 1, 2, up 1. 1, 2, up 1. 1, 2, up 1. Okay, well along with that, my asymptote line shifts left 2 also with it. So my asymptote is definitely moving along with that line. So my asymptote now is x equals -2. Alright, so just a little bit more review on graphing logs. We talked a little bit about ln and e. So with the log base e, log e to the x is the same as saying ln to the x for all x's greater than 0. So this is read ln of x, or natural log of x. Alright, you do have the natural log button on your calculator. There's 3 buttons up. So on button and 2 buttons up. So ln of 1, you can type it in if you want. That automatically equals 0. We talked about ln and e already. They cancel each other out, so you're left with a 1. ln and e again cancel each other out, so you're left with an x. And if you have ln of x equals ln of y, if you have ln on both sides, it's doing the same function to both sides. So technically those like cancel each other out, and you have x is the same as y. So just a couple reminders. So if you have in this problem something like this, if I bring e to the top, I have the natural log of e to the -1 because I bring it up to the other part of the fraction. Now this part cancels out, ln and e, so I just have the answer of -1. Letter B, ln and e cancel, so you just have the answer of 2. ln and e cancel again, so I have an answer of 0. Now letter D, ln and e cancel, so you have the 2 in front. Now technically this is the exponent has a 1, so it's 2 times 1 or just 2. Now in some of these problems you don't actually have an e in it, so don't just cancel it out. If it doesn't have the e, you actually do need to type it into the calculator. So hit ln 2, and then you have 0.693. Natural log of 0.3, so negative 1.204. Natural log of -1 doesn't exist, so non-real answer. So you can't actually do that, so no solution. Okay, so the values have to be always be greater than 0 to be able to calculate it. Alright, last part here on the bottom, find the domain of the function means figure out where the asymptote is. So for the natural log function, the asymptote starts at just like above, x equals 0, just like the logarithm. So if this function goes right to, that means everything, including the asymptote, goes right to. So the asymptote starts at x equals 2, and the graph goes off to, the graph would go off this way, to the right. So the domain is from 2 to infinity. Now letter B, it shifts up to, but shifting up to doesn't actually affect the asymptote. The asymptote stays there on x equals 0, so it starts at 0, so we say the domain goes from 0 off to infinity. And this one, because the graph shifts left to, that means the asymptote goes from 0 to -2. So we say the domain is from -2, from wherever the asymptote is, off towards positive infinity. Okay. That's it for tonight. Thank you. Talk to you later. Bye.